Good morning, or afternoon, or evening, whenever you're watching this show. My name is Professor Shannon Gracie, and today we'll be covering Introduction to Functions. We are using the Blitzer Introductory and Intermediate Algebra text for college students, and here we go. We will be learning how to find the domain and range of a relation and determining whether a relation is a function as well as evaluating a function today. So let's warm up by evaluating this equation. Y equals the opposite of x squared minus 22 times x plus 5 at x equals negative 3. So I know you guys can do this one. Pause the movie, give it a shot. Let's see how you did at, whoops, x equals negative 3. We have y equals the opposite of negative 3 squared minus 22 times negative 3 plus 5. So all we've done is we've been given this value of x equal to negative 3. So anytime we saw an x in the equation, we placed a negative 3. And it gets a little tricky here with all the negative signs in the problem. So let's see how you did. This will yield a result of y equals the opposite of 9, because when you square that negative 3, that negative goes away, but the negative on the outside does not. Minus a minus is plus, so we get plus 66 plus 5. So at the end of the day, we get an end result of 62. How do we do on that guy? Awesome. All right, so here we go. We move right in to learning the definition of a relation. A relation, very simple. A relation is any set of ordered pairs. The set of all first components of the ordered pairs is called the domain. So get used to this word. You'll see it for the rest of your math life. The set of all second components is called the range of the relation. So just a very real world example for you here. Find the domain and range of the relation, right? So here, right here, these are all domain values. And here we have, actually let's modify that a little bit. These are the elements of the domain, the type of vehicle. And then over here, number of wheels, that's the elements, those are the elements of the range. So putting that in a more, organized fashion, we can say domain, it's a set, so we put set brackets, and we've got a car, a motorcycle, and a boat. The range is the number of wheels. So we've got 4, 2, and 0. And we're done. Oops. See, that's not so bad. But you do need to learn this vocabulary because it is going to be used in definitions later down the road. Namely, definition of a function. So definition of a function is a correspondence from a first set called the, you got it, domain, to a second set called the range. Awesome. such that each element in the domain corresponds to exactly one element in the range. Example to illustrate with a picture and a chart if a relation is a function. So remember, the trick is each of the domain values has to map to exactly one range value. The range values can be repeated, but you can't have two different domain values map to the same range value and have it be a function, right? So let's take a look at what we have. The domain, if we just kind of made a little list here, D for domain, we've got -6, -1, 0, 1, and 2. So I'm just listing the first element in each order pair. And then the range is just 1, and we won't repeat that 1. Now look what's happening here. They each map, each of these domain values map to this repeated range value. So here, this actually is a function because each of these guys in the domain maps to exactly one range value. It's okay that that range value is repeated, so it fits the definition. Another way to look at this is to make a picture of it. So if you look over here, let's label our graph. You always want to label your graph. I'm going to have it have a regular scale, so each one of these tick marks has a value of 1. And if we graph each of those ordered pairs, that's -6, 1, -1, 1, 0, 1, 1, 1, and 2, 1. Notice that there are, if you look up and down, okay, up and down, you won't have two input values, two x values that go to different y values. Okay, so that's another way to see kind of a picture of what it would look like. Now let's put our result in. So we have ascertained that this is a function, right? So the relation is a function. Right? The domain, I'll just put D for domain, was -6, -1, 0, 1, and 2. And the range is the set of just one element, 1. Okay? Okay. So why don't we do this? Go ahead and pause the movie and make a little chart, identify domain and range, make the picture of the graph, and then you try to figure out if this guy is a function or not. So pause the movie and do your thing. All right, let's see how you did. So again, if we make a list of domain and range, we have, let's go from, least to greatest. We've got -2 is the smallest domain value. It's repeated. And 3 and 4. And then the range, we have -5, 0 is repeated, so we'll just put it once, and 3. So -2 corresponds to 0. And look, -2 corresponds to -5. So do you see this violates the definition for a function? You still have a relation, but you have a domain value that is going to two different range values. Therefore, this is not a function. But let's continue our mapping just for fun. 3 maps to 3 and 4 maps to 0. So it's because of that -2 mapping to both -5 and 0 that we have a relation which is not a function. So let's make our picture. So we had 3, 3, -2, 0, 4, 0, and -2, -5. Now notice in the picture, right, the other one, if you drew vertical lines, you would never hit two ordered pairs. You'd never hit the graph twice. With this one, if I were to draw in vertical lines, do you see I would hit right here? I would hit 2 points if I did a vertical line here. All right, so we'll be learning that shortly. There's something called the vertical line test that we'll learn. All right, so the relation is not a function. And we put our results in set notation. All right, ready to go? Now here's some information. I mean, functions are a little hard sometimes for people to grasp, so I thought we would just talk a bit about them. So functions are often given in terms of equations, right? So we were working with a list of ordered pairs, but we often are given them in terms of equations, right, rather than as sets of ordered pairs. So if you consider this equation below, which describes the position of an object in feet dropped from a height of 500 feet after x seconds. This is an equation, so it has infinitely many ordered pairs, right? That's when we start, connecting all the dots, right? So the variable x is a function of the variable y. For each value of x, there is one and only one value of y. The variable x is called the independent variable because it can be assigned any value from the domain. The variable y is called the dependent variable because its value depends on x. When an equation represents a function, the function is often named by a letter, such as f, g, h, or capital F, G, or h. Any letter can be used to name a function. The domain is the set of the function's inputs, what you can put into the function. And the range is the set of the function's output. Just like a calculator, what comes out after you put a number in and perform an operation. So if we were to name our function f, the input is represented by x and the output is represented by f at x. Okay. So the way you read this is read either f of x or f at x. I will often say f at x so that you don't think that these are being multiplied. Right? They are not being multiplied. It is evaluating the function f at x equal to some value. So this equation here, y equals negative 16x squared plus 500, it's in equation notation. Okay? If we put it in function notation, since the y is isolated, we could just write it as f at x equals negative 16x squared plus 500. So the nice thing about this notation is that it's got sort of a placeholder, so you see exactly what you're plugging in for x. All right, so now here I have a wee bit of a typo here. Let's evaluate our function after 1 second. Okay. After 1 second. So we would be evaluating f at 1. That will equal to negative 16 times 1 squared plus 500. So all we did was, wherever there was an x, we put in a 1. So f at 1 will be, well, negative 16 times 1 is negative 16, so we will get 484. Well, what does that mean? After 1 second, the object is 484 feet above the ground. So this, you'll see this if you take further math. It's really a special case of the position function, where they've already inputted certain things. So that was our result, and that is what it means. All right. So here's a little bit of practice evaluating functions. So we've been given a little bit of a complicated function, and we're evaluating this function at several different values. Right? So here we go. F at 0 will be negative 0 cubed minus 0 squared minus 0 plus 10. So everywhere that I saw an x, I put in a 0 on this one. So when I complete this operation, do you see this is going to be 0 minus 0 minus 0 plus 10. So we get f at 0 equals 10. Okay. So why don't you go ahead and pause the movie and try B, C, and D, and then start her up and see how you did. Good luck. Okay, let's see how you did. F at 2 will be negative 2 cubed minus 2 squared minus 2 plus 10. So again, wherever there was an x, this time I put in a 2. Okay. So f at 2 equals negative 2 cubed will be negative 8. 2 squared is 4, so we're subtracting 4. And then minus 2 plus 10. So f at 2 will have an end result of negative 4. Let's look at negative 2. So now we're going to have the opposite of negative 2 cubed minus negative 2 squared minus negative 2 plus 10. And just double check that you didn't mess up a minus. We've got negative 2 in each of those. And so we'll get f at negative 2 is equal to minus a minus becomes positive. That's all within what's being cubed. So we're going to get a positive 8. Negative 2 times negative 2 is positive 4. So we'll be subtracting 4. Minus a minus 2 is plus 4. And then plus, oh, my bad, I was making up my own math again. Notice that this will be minus a minus 2 is plus 2. And then we'll have our plus 10 hanging out. And so at the end of the day, f at negative 2 will be equal to 4 plus 2 is 6 plus 10 is 16. Now it turns out that you can add functions, right? So you do the same things that you've been doing in these other problems, right? But you're going to end up doing it twice and summing each of the results. So just take it a step at a time. You're going to have, so f at 1 will be the opposite of 1 cubed minus 1 squared minus 1 plus 10 from our original. So that there, I'm going to put brackets around it, is f at 1. F at negative 1 will be the opposite of negative 1 cubed minus negative 1 squared minus negative 1 plus 10. So we'll get positive, actually negative 1 when we cube that, minus 1 plus 10. So that's our f at positive 1. F at negative 1 we'll end up with a positive 1 because minus and minus is plus, and that's all inside what's being cubed. And then we'll get minus 1. Then this negative will go away after we square it. Minus a minus 1 is plus 1. And then we'll get plus 10. So, sorry, we'll keep our notation going. So we'll end up with 7 plus 11 with an end result of 18. So just to keep track of what all we did on this guy, f at 1 ended up being all of this, and when we worked it out we got 7. F at negative 1 ended up being all of this, and when we worked it all out we got 11. And then we added them together to get 18. All right, so let's put our happy little box around the answer. Okay, so here we go. The next example, actually this will be example 4. we'll be finding the indicated function and domain values, and we'll be using this information on the table. So we don't have an equation for h, but we have 5 sets of ordered pairs, all right, from evaluating the function h. So if I have an input of -2, what is my output? Good. It's 2. Right? Because of this ordered pair here. -2 goes in, 2 comes out. H of 1, what do you think? Great, it's going to be 1. That's from over here. When 1 goes in, a 1 comes out. Now this one's a little tricky. It's giving you the function value, the y value, and it's asking you what x values correspond. So with this guy, do you see that h of x is 1? H of x is 1 here and here. Right? So it's asking you which x values correspond. So it's going backwards. So when x equals -1 and +1. All right, and that wraps it up for today. I think that one's a relatively short lecture. So have a fabulous day. Make sure you do some of the assignment from 8.1, and I'm sure you'll be hearing me shortly. All right, bye.